Welcome, my viewers. Briefly, we are going to look at probability, the basics in probability. Now, probability is a way of predicting an event. We use it to tell how likely or unlikely an event will occur. So the concept of probability is used to frequently answer some questions in our daily life. For example, if we ask which party will win the 2021 elections in Uganda, is it NRM, is it NUP, is it FDC? So we use probability to answer such questions. And for probability that an event will occur, we take the number of favorable outcomes divided by the total number of outcomes. We are going to look at this example and we understand more about it. We have two dice are simultaneously thrown and the sum of their scores observed. Find the probability of getting a sum which is an even number, a sum which exceeds 10, and a sum which is divisible by 2 or 3. So you need to know that a dice has faces marked 1 to 6. So if there are two dice thrown at once, we can draw a table as you can see. Remember, one die is marked from 1 up to 6 and another from 1 up to 6. So this table can help us to get the total number of outcomes. What you are seeing here is the total number of outcomes. So if this is dice 2 and this is dice 1, dice 2 1 to 6, dice 1 1 to 6, and dice 2 1 to 6. So if the two dice land, we can have one on one dice and one on the other dice, or one on one dice and two. So these are possible outcomes. And the total, when you count all of them, this is 6 times 6, you get 36. The total outcome, we have 6. Total outcome, we have 36. Sorry, that is 6 times 6, 36. Now, we are told to determine the probability that the sum which is an even number. Now, for an even number, we can check. If one die is 1 and another die, like here, 1 plus 1, this is an even number. If you add, you get 2. This one not, this one is okay. This one not, this one is okay. This one is 7, not even. This one is not even, this one is even. Not even, even. Not even, even. This is even, not even. Even, not even, because it is 7. This is 8, so even. This is 9, not even. This is 5, not even, but this one is even. This one is not even. This one is even, not even, even. Even this one is even, not even, even. 5 plus 3 is 8. 9, not even. 10, yes. This one, no. This one, yes. Yes, yes. So when you count the number of favorable outcomes, that is when the sum is even. The sum, that means you add the number which appear on one dice and the number which appear on the other dice. When you get the sum, it should be an even number. So here, 1 plus 1 is 2. Here, 1 plus 3 is 4. 4 is even. 1 plus 5, 6. So that's how we have identified the favorable outcomes. So how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the probability for a sum which is even, the favorable outcome, we have 18 over 36, which gives us by 18 once by 18 2. So this is a half. Now, secondly, the sum which exceeds 10. Now, the sum which exceeds 10 along this line, I think the biggest is here, 7. So it is less than 10. Along here, when you add, no sum which is exceeding 10. Apart from here, this is 5 plus 5, you get 10, but it should exceed. This is just equal. So we start with 5 plus 6, that is 11. So this one exceeds. So this one exceeds 10. Even this one exceeds 10. Even this one exceeds 10. So we get the probability that the sum exceeds 10 we have 3 out of 36, that is 1 out of 12. So part C, a sum which is divisible by 2 or 3. Now of course we have got the one which is uneven. Any even number is divisible by 2. So far you got 18 if you remember. So we are going to start from there and we find when they say 2 or 3, we must also add that outcome where we have the sum which is divisible by 3. So it was 18. Let us see. 1 plus 2, this one now will be divisible by 3. Let us check here. This 5 not divisible. Here it is here divisible by, let me use another color, divisible by 2, those are 2. 2 added on 18, those are so far 20. Here no, and here no. When you come here, yes, divisible by 8, not divisible, this is divisible. Even this one is divisible, and this one is divisible. So let us see. So on top of 18, because 2, we said the sum which is an even number, we got already 18, we had already counted, or 3. So when divisible by 2, that means it is even number. Then of 3, we also find the outcome where the sum divisible by 3. So let us see, 1, 2, 3, 4, 5, 6. So 6 plus 18, because they are 2, it should be divisible by 2 or 3. We add 18, first of all, for all the even number, the sum giving even number, then plus those ones which are divisible by 3, we have got 6, getting 20, a total of 24. So the probability that divisible by 2 or 3, that is 24 over 36. So by 6 you get 4, by 6 you get 6, by 2 you get 2, by 2 you get 3. So that number is done. So we have this number to try. A black die and a white die are thrown at the same time. Display the possible outcome. Find the probability of opening a total of 5, total of 11, a 2 on a black die and a 6 on a white die. So that is the number. Draw. Make one die to be black and one die to be of the other color, which is white. Then you formulate the sample space just like here. After that, you'll have to find a total of 5, the probability when you have the total of 5. For example, when you have 1 and 4, there is a 4 and 1, there is a 3 and 2, so you find that probability. Total of 11, the same. Now here, we have a die and a coin tossed. Find the probability of getting a tail and uneven numbers. How do we draw a sample space, the table for that sample space? Let us have this table here. Yes. Now here we have a die and a coin. This time one side is of a coin. Here a coin have a head and a tail, but the die has got 1, 2, 3, 4, 5, 6. So here we have the head and 1, add and 2, add 3, add 4, add 5, add 6. Here we have tail 1, tail 2, tail and 3, tail and 4, tail. So that is the sample space you can draw if a number is about to die and a coin. So they want us to find the probability of getting a tail and an even number. Now, of course, here we don't have a tail, so the tail is here. Tail and even number, we have that is 1, that is 2, and that is 3. So the probability of tail and even number will be 3 out of the total number of outcomes. The number of outcomes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is by 3 once, by 3, 4. Now a tail and a number not less than 4. A number must be greater than 4. That means we take 5 and 6. A number which is not less than 4. If it is not less than 4, if they say not less than 4, even the 4 is inclusive. So a number not less than 4, we begin with 4. 4 is not less, it is equal, so it is not less than 4. 5 is even greater than 4, and 6 is greater than 4. So again here, the probability will be, for part B, this was for part A, probability of a number not less than 4, and you have a tail, we shall be having 3 out of 12, which is also a quarter. So try out this number, where we have a fair coin, tossed, and a fair die, Lord. They want the probability of obtaining a head and a 6. Again, you will follow the same procedures here to do it. So now, let us look at the probability tree diagrams. Probability tree diagrams are used to determine the possible number of outcomes or the sample space, as we are going to see in this example here. But the rule you have to follow is that when the required outcome is given by a path along the branches of the probability tree, we multiply the probabilities along that path. For example, we have this diagram here. We have this path, mango, we have mango and mango. That is one path. So we get the probability here times the probability here times the probability here. So the answer we get will be the probability for this path. When the probability of the required outcome is given by more than one path in a probability tree, we add the probabilities resulting from each path. For example, we may need 2 mangoes and orange. This is mango, mango, orange. When you come here, orange, mango, mango. So we shall have this path here and this path here. We first multiply, we get the answer, and even here we multiply, we get the answer, and we add. We are going to understand it more from this example here. Now here we are told that a basket contains 6 mangoes and 4 oranges. So if this is a basket here, we have 6 mangoes and 4 oranges. Now, 3 fruits are removed from it without replacement. That means when you remove right now we have 10 fruits, but we remove 1 without replacement, that means the remainder will be 9. You again remove, the remainder will be 8. So you need to understand the meaning of this one without replacement. Here we are told to use the tree diagram to work out the following probabilities. I've drawn a tree diagram for you already, where we are going to remove how many fruits? Yeah, 3 fruits are removed from it without replacement. So this is the first draw. You remove 1 fruit. You can remove either mango or orange. Now after removing a mango, this one alone can produce another branch. If you remove a mango, you can either, for the second row, it is possible to remove a mango or orange. Still, if you removed one orange for the first row, then the second row, there's a possibility that you get a mango, or there's a possibility of getting an orange. Each path will generate a branch. Now when you remove the mango and the mango, for the second row, or removing a third fruit, you either get a mango again or orange. Even here, if you had a mango for the first removal, and again the second one you get orange, then the third one here, you can either get a mango or orange. The same applies here. If you had a mango, you can get a mango or orange. Here, if you had orange, you can get a mango or orange. So, first fruit, that is the step here. Second fruit, the third one, you need to know that we have two items here. Mango, orange. So for each draw, for each path, you have two options. Mango, orange. Mango, orange. For this mango, orange. So here, that means we are getting, for the first path here, we are getting a mango, again a mango, and a mango. For this one here, mango, mango, orange. Mango, mango, orange. For this one here, mango, orange, mango. Mango, orange, mango. Or mango, orange, orange. We have completed the upper part. If the first fruit was the mango. Now, what if the first fruit was orange? You can get orange, then mango, mango. Or you can get orange, mango, orange. Or you can get orange, orange, mango. And lastly, orange, orange, orange. So, these are the possible ways if you pick three fruits. You can pick a first mango, again another mango, mango. Or mango, mango, orange. So long as you are getting fruits. But what you should know, here we are removing fruits without replacement. So here, to pick the first mango, we have 10 fruits. So for the first mango, we shall have 6 out of 10. Whereas for orange, it will be 4 out of 10. Now, for the second row, now remember you have removed one fruit. For this, the remainder would be 9. Here we have 10 fruits. Here we shall have 9 to pick from. So here we are picking from 10. But here we are picking from 9. Meaning that to get a mango here, if we removed the first mango, that means how many mangoes are remaining? 5. So we'll be having 5 out of 9. Now if we removed the first mango, to remove, for the second row to be orange, the first one was the mango. Now the second one is orange. That means you will still have 4 oranges here, but out of 9 because one fruit was removed. Now here, once again, if you are to remove a mango, that means you have removed a mango, another mango. Now you are left with 8 fruits. You remove the mango and the mango. And if you remove the 2 mangoes, that means you have 4 here now. We have 4 mangoes. So you'll be having 4 out of, now it will be 8 because the fruit was removed without replacement. Now here you have mango, mango, orange. If you remove the a mango and a mango, those are 2 fruits removed. You haven't removed the orange. Orange will be still 4. So this will be 4 over 8. Let us come to this one here. Now for this, that means you remove the first mango, then you remove the orange, then you are removing a mango. So we have 8 fruits, you should remember. But now for the mango, you already removed the first one. So out of 6, you remove the 1 here. For the second row, you just remove the mango, so you still have 5. These are 5 out of 8. Definite here will be 3 out of 8. How have I known? 5 out of, you look here, 6 out of 10, this is 4 out of 10. When you add 6 plus 6, you must get 10. So even here, 5 and a 4 gives you 9. Here, 4 and a 4 gives you 8. So this could be 3. That trick can also work for you, but you need to cram to understand. How have I known that it is 3 out of 8? Let us prove. Now this is a mango. You remove the orange, then you are removing a second orange. So before you remove the 2 fruits, now out of 10 you have 8 fruits, but 1 fruit was a mango, another fruit was orange, meaning that this one now, the 4 oranges are no longer 4, they are 8, because of here you removed 1 orange already, so you are left with 3. But remember, these are 2 fruits here, 1 fruit, another fruit, so out of 8 you have 3 out of 8. Let's come down here when the first one was orange. Now for the second to be a mango, that means you do not touch on mangoes. Mango you still have 6. But remember, after removing orange, 1 orange, you are left with 9. So 6 out of 9. Definitely this one will be 3 out of 9, because this is 6 plus 3 to get 9. Or you just know that if I remove the first one to be orange, out of the 10, I add 4 oranges. When I remove the 1 orange, I remain with 9 fruits. But remember, after removing 1 orange, out of the 4, you are left with 3. That's why I've said 3 out of 9. Come here. If you have removed the orange and a mango, these are 2 fruits. But 1 is orange, 1 is a mango. So you have 8 orange fruits remaining. So how many mangoes are remaining? This was 1 mango removed. So you have 5 mangoes remaining. But remember, you have 8 fruits, simply because this is 1 fruit, another fruit, they are no longer 10. Without replacement, when you remove a fruit, the number reduces. That's why we are having 10, here we have 9, here we have 8. So this one definitely be 3 out of 8, because this is 5 out of 3. When you add the 2, you must get 8 out of 8. Yeah? That's why I'm writing 3 out of 8. Or again, you can get it from first principle, that if I remove the first one orange, the second one mango, the third one orange. So you removed 1 orange already, you are left with 4. So that will be 3 oranges out of 8, because 2 fruits are removed already. Down here, you remove orange and orange. That means you are left with 2 oranges. But mangoes, you haven't removed any. Then for the third one to be a mango, you still have the 6 mangoes out of 8. This will be 2 out of 8. Let us find out. 4 oranges. You remove the first one orange and the second one orange. Those are 2 oranges removed, remaining with 2. Definitely you have 2. But out of 8. Now here they are telling us to find the probability that for 3 mangoes removed. 3 mangoes, I think it is only here when you have a mango, and a mango, only here. 3 mangoes. So it is just 1 path. We don't have any other option where I have 3 mangoes. These are 2, 2, 1, 2, 1, 2. So here, so what we do, we just multiply. So part A, since it is just 1 path, only like this, we take 6 out of 10 times 5 out of 9 times 4 out of 8. And the answer is, we get 120 out of 720. If you simplify, you get 1 out of 6. Now, part B, a mango and 2 oranges. 1 mango, 2 oranges. We have here. 1 mango and 2 oranges. We have here. So here you can see we are following. We have different paths. We have this one here, a mango, orange, orange. We have even here orange, mango, orange. So here we have two parts. So we are going to add. These two will be added. But before adding, we first multiply. We are going to multiply 6 out of 10. Then times. We are moving along this path from here, here, here. Times 4 out of 9. Then times 3 out of 8. That is for this path here. Plus. Now another one is here. We have orange, mango, orange. So orange, mango, orange. Orange, that is 4 out of 10 times 6 out of 9. This one here. Orange, mango, orange. Times 3 out of 8. Just press the calculator and get the answer. So we are forgetting this one. Even here we have 2 oranges and 1 mango. So this one must also be added. So we shall be having orange, orange, mango. That is orange 5 out of 10 times 3 out of 9 times 6 out of 8. So when you add the whole of this, press the calculator very well. The answer will be 3 out of 10. Now let us look at another example about a probability tree diagram. Here we have a bag having 4 red and 5 blue beads. Now 2 beads are taken out of it. What is the probability that they are both blue? Now you need to understand here that if the first bead is put back, that means we shall be having 9 at any selection. We shall be having an option of 9 because after taking the bead it is put back. So here let us use this tree diagram. Here we have 9 beads. Now to pick the first red, there are 4 red in the bag. That means we shall be having 4 out of 9. And for blue, we shall be having 5 out of 9. Then after picking, it is returned. Now to pick another red, again, we shall be having 4 out of 9. The number remains 9 because after picking, it is returned. Now to pick a red and then a blue. For the case of blue, again, we shall be having 5 out of 9 because after picking, the bead is returned back. When you come here, picking the second blue, the second bead which is red, we have option of 9, but they are 4 out of 9. Same applies here. We are having 5 out of 9. I think you can see that here you return the bead. The first bead is selected, then returned. So we shall always be having the same number of beads at each selection. So that's why you need to understand the difference. Like in part B, they said if the first bead is not replaced. So we shall come to that. Now let us see. What is the probability to pick blue? Now here we have red, red. We have red and red. Here we have red, blue. Here we have blue, red. Here we have blue, blue. Now you are asked to find the probability when they are both blue. It is here. So and if we just take on one path according to the rule, we shall be getting 5 out of 9 times 5 out of 9, which is 25 out of 81. Now part B, if the first bid is not replaced. Now after picking the first bid, here for red we have option, probability is 9 out of 9, 4 out of 9, here 5 out of 9. Let me change the color for the second selection. Now for the second selection, remember here the first bid is not replaced. After removing the first bid, now we have 8 bids in the basket, in the bag. Meaning that here we shall be having, if the first one was red, to pick the second red, we shall be having 3 out of 8. Remember, we have not replaced this red. Now here, if the first one was red, now the second one to be blue, blue was not selected in the first selection. If we take this path here, so meaning here the probability will be, for the blue, we shall have 5 out of 8. Now, we come down here. If the first one is blue, that means we have first option is 5 out of 9. Now, if the second one is going to be red, that means we shall be having 4, but this time out of 8. When you come to the second bid being blue and the first one was blue, the first blue was removed, blue were 5, now we are left with 4. So we have 4 out of 8. So blue is for second part, don't forget. So still here we have 4 out of 9, 5 out of 9. Now blue, have we changed the color, but have used the same tree diagram. The second part says that the first bid is not replaced. So how do we get the probability that both are blue? So we take this path here, meaning we shall be getting, for probability, when you have the first one blue and the second one blue, definitely we shall be multiplying 5 out of 9 times 4 out of 8. This is part A, this is part B. So here we get, if we multiply 9 times 8 here and 4 times 20, we get this one. We shall be getting 20 out of, press the calculator, 72. And this reduces to 5 out of 18. So that is the tree diagram. You should always understand when they say the first bid is not replaced or not put back, the number remains the same. But if you remove the first bid and you don't return it, the number keeps on the same. So we have this number to try. Now this time we have 3 items, 5 red balls, 3 blue balls, and yellow. So the tree diagram will look like this. So you should always put 3 branches on each path. So a ball is drawn and not replaced the second, so 2 times. So you need to work out that number. The answer is given here, so try it out.